Okay, question 7 deals with solving of triangles. Okay, let's have a look. In the diagram alongside, O is the center of the circle. Now you can stop reading at that point. Okay, if O is the center of the circle and that angle has been indicated as a theta, then we know that this will be 2 theta because the angle at the center is twice the angle subtended on the circumference. A little bit of geometry. But we also notice that there are radii in this diagram that are going to be equal. So if we need it, let's indicate it. Okay, so let's read on. With a radius r as shown. So these are r's. OB is r, OC is r, both radii. Okay, let's see. The minor arc BC, which is this, remember every circle where there's a chord given, that chord divides a circle into a major component and a minor component. That's what the minor arc means. Okay, it subtends an angle of theta at point A and an angle of BOC at the center. We're supposed to prove that this chord here is twice r sine theta. So we're required to prove that BC is 2r sine theta. Now let us start off by saying let's join BC and we form a triangle. Okay, now we can work with that information. If we want to work with BC, look at what you've got. You've got this, you've got that, and you have the other side. This is what you want, so you can, in that triangle, apply your cos rule if you want to. Okay, so let's see where that takes us. BC squared is r squared plus another r squared minus 2 times r times the cosine of the angle subtended by the 2. Okay, now look at your answer. You only want a sine in your answer. So we will most probably have to change something along the way, but let's clean this up. 2r squared minus 2r squared, and I'm going to change this to 1 minus 2 sine squared of theta, my double angle. And I'm only choosing this because of where I am going to. So I'm constantly peeping at where I'm going to. Okay, now if I look at this, this gives me 2r squared minus 2r squared and the bracket. So I'm going to distribute there. 2r squared minus 2r squared times 1 is minus 2r squared. A minus times a minus is a positive. 2r squared times 2 is 4r squared sine squared theta, and all of this is equal to BC squared. Okay, so can you see how I analyzed my diagram and how I based my choice on that? Okay, let's have a look. If I now do the math, those two cancel each other out. So I have, look at this, 4r squared sine squared theta. Therefore, I've proved that BC is the root of that, because this is what BC squared was. So BC is 2r sine theta, and I proved the problem. Okay, so always go to your diagram. Analyze your diagram, and remember, why did I make my choice? Because of the way that information was supplied. I wanted this, so I have to have side included angle side to use my cos rule, or in this case I can also use the area rule if they asked me anything about area. When do I use the sine law? Folks, I use the law of sines. If I wanted this, I had to have that, yes. And if I wanted, this is what I wanted. So I need another combination of things that lie opposite one another to be able to apply my sine law. So let's look at the alternative. The alternative would have been to say BC over, let's do that, BC over the sine of 2 theta equals R over, now I need these two angles here. Okay, I know it's isosceles, so each of the angles, let's quickly calculate here. Angle OCB will be 180 degrees minus 2 theta halved, because it shares it with angle B. So this is 90 degrees minus theta. Okay, so I have r over the sine of 90 degrees minus theta, and then BC will be r times the sine of 2 theta, that multiplies to the top, and this sine in the first quadrant is positive sine because of the 90, becomes the cosine. So I have r times 2 sine theta cos theta over the cos of theta. The cosines of theta disappear, and I have what I wanted to prove. Okay, so either way you get to the same answer.